This is a cutaway of the Corvette. I've already talked about the motor in blue, and I will talk about the 4 battery modules and how I made them in the video after this one. So today's video is to talk about what's in red, the control system. I received a completed Tesla Model S drive unit from a dismantler in California. And as I described in the earlier video on the motor, I disassembled this unit and salvaged the individual pieces. So in this video, I'll talk about the salvage control system. This picture is just an end view of the control side of the Tesla drive unit before I removed it from the pallet. This is the controller side of the Tesla Model S drive unit that I dismantled. The motor half I talked about in my previous part 2 video, so in this video I'll focus on this half. The casing has been cut back as much as possible to minimize the size of the unit, and then in the next picture I'll show you what I did to the inside to make it usable as a control unit for my conversion. I replaced the internal Tesla circuit board with a circuit board from openinverter.org. It's a European-based company that makes a number of different control boards for the do-it-yourself electric conversion person. They make them for a number of different manufacturers. For Tesla, they make a board for both the Model S and the Model 3/Y. So a very good way to convert and very economical. The circuit board requires programming with a number of different parameters to control how the unit behaves in the particular application that it's been used. But once you get a feel for all the different parameters and how they're used, it really is quite simple to implement.
Okay, what I'd like to do is a status update of the electric Corvette project. In the beginning, I talked about kind of 3 or 5 major stages to the project. Step number 1, or stage number 1, is working on the motor. The motor is now complete and is operational, ready for installation into the car. The second step was the control system, which is here and part of, well, basically the entire setup that's on the board here. Step 3 is the battery system. Step 4 is what I call the ancillary systems: HVAC, power steering, power brakes, and so on. And then the last step is just the integration of all of this with the existing Corvette control system, so that when I do need to work with electric version will work, even though there's no gas engine or transmission. So today I just want to briefly update on the status of the control system. If you zoom in here, Tracy, and look at the controls that I briefly have just set up as a demo. This switch simulates turning on the ignition of the car. This button here actually activates the controls for the controller. So if I just press that, and that tells me that it's energized, ready to go. I have a large toggle switch here that is used for gear selection. So green with an F is going forward, N in yellow is neutral, and then R in red is reverse. So if I put it back in forward, I have it set up right now with just an extra throttle that I had for an electric motorcycle project. I do have the actual shifter or foot pedal out of the Corvette, and I'll integrate that here in one of my next steps. But it's basically going to function the same as the throttle that I'm showing right now. So I'm in forward. If you look at the motor, so I have that turning in the direction of which a Chevrolet V8 engine would turn to drive the rear differential of a car. So in that counterclockwise motion, if I go to neutral, nothing happens. So I think of this as kind of a safety mode. If you need to step out of the car, but you want to leave everything on, nothing will happen. And then you go in reverse, and the motor spins backwards. This system is out of a Tesla, and I'm not going to slow the reverse speed. It'll be basically the same as if I was going forward. So it may want to go faster in reverse than you want it to, so you just have to kind of watch that. There may be a way for me to make it go slower in reverse rather than what it does in forward, but I'm not sure yet. Okay?
This is a picture of the control box with everything that you saw on the test bench installed and ready to be mounted into the Corvette. The control system wiring, yes, it's complicated, but openinverter.org does a nice job of providing various wiring diagrams, suggested wiring diagrams for the do-it-yourself builder to install the components. The lid of the box is originally was going to do aluminum, but then realized I need to change that to plastic to allow a Wi-Fi signal to go from the box when it's installed to the user with their laptop to do any of the parameter programming. This picture is the front view of the control box prior to installation. All of the electrical connectors are quick connect, and let me just walk through the various connectors. The upper left is the positive and negative high voltage battery connectors. To the right are the three-phase connectors that go from the control box down to the motor. The 12-pin connector to the right of that goes directly from the control box to the center console that has all the controls to actually run the vehicle. And the far right is a 4-pin connector that goes down to the encoder of the Tesla induction motor. The lower left is a 4-pin connector that also goes to the high voltage of the system, and that's where the charger and DC to DC converter connect. To the right of that, there's two water connectors. One is an inlet, which is right underneath the three-phase connectors, and then the one on the right is the output of the water, I should say coolant. So how I run those coolant lines will be described in a later video. This is a view of raising the control box into the rear of the Corvette. The control box essentially takes up the space where the exhaust mufflers were originally located. This is another view of the control box being raised into the bottom of the Corvette. This is a picture of the center console as shown on my workbench prior to installation in the vehicle. The details on the controls are explained in my introductory video if you want more detail.